So AI for speech recognition, as I mentioned, there was this era that now is kind of subsided a little bit of voice assistants. And the reason it became so popular and a lot of companies invested is the technology finally matured. You could use deep neural networks to get a very high degree of confidence in speech recognition. The second thing about AI, and I'm sorry for some reason the image, one of the images is not so great, but basically it's computer vision, again, unstructured data where you can recognize a dog, or you can, again, it's a feature that we launched and translated in 2015. You can, on device, to basically translate anything visually, any sign or any menu item, you can translate it quickly and even use augmented reality. That's, again, very proud of all those early innovations that we did in one of my teams, Google Translate. Now, machine learning 2.0, that's how we called it that time AI, because as I said, Google was very early using machine learning, what's called statistical machine learning, for natural language processing. And what I mean by that is that, to some extent, it was funny that in the past, I had to explain why natural language processing was so important, because in many cases, the first wave of AI revolution was limited to companies like Google. Google is by design is a language company. But now we know with the power of ChatGPT how much language processing is important. But on a high level, we as an industry, technology industry, want to enable users to manage their world with technologies, with the power of language. That's the most natural interface, whether you type or talk or whatever you do. And language processing, obviously, is a critical component of many technology products. As I said, now I don't think I need to explain it. In the past, I did, because it was limited to companies like Google that did it. It's extremely complex topic. That's why you needed the breakthrough is relatively recent to get to really, really good level of natural language processing. It's very complex because languages are hard. Languages, all those examples are real-world examples. Languages could be ambiguous. For example, the meaning of I'm learning Go could be either programming language or game. It could vary. There are multiple ways to say the same thing. I could say I work for Google. I could say Google employs me. It's also evolving. There is a ton of slang that, like, for example, this is a real slang in Italian, TVTTTTB. It means I like you very much. It also could be extremely contextual, and humans understand it, but machines not necessarily, or at least until very recently they didn't. They were out would have multiple meanings. That's why the amount of variances in languages, because they're so rich, is insane, and that's why it required a very different technology to do it well. So in languages AI, basically the breakthrough was that you use neural networks on huge amount of training data. I mentioned transformers, that's attention is all you need at the most defining papers that is a baseline. Both the paper and the researchers that wrote it and the teams like me and others who worked on it was very define all this AI revolution, so next wave of AI revolution we are going through. So this is natural language processing for one language. You basically understand that somebody said something in English in a much better way, and I will show you a couple of examples. And the second one was neural machine translation. That's what I call bilingual natural language processing. You understand language A and translate it to language B. In both of them, they both were the baseline for all this revolution. So a little bit of history. Generative AI revolution actually started in 2017. As I mentioned, in 2016, my team at Google launched neural machine translation, the first what we now call commercial LLM. It was a huge technological breakthrough that I will talk about it both on software and hardware level. And that led to new wave of research that culminated with this paper called Transformer Attention All You Need. That paper was basically the breakthrough that enabled current generative AI revolution, because it basically showed new ways of processing data and especially understanding what people say and generate responses. The first product was called bidirectional encoder. And that's basically a product where we basically could look at both directions of text, and we also could do pre-training and fine-tuning. So that was the first productization of transformer technology in 2018. That was initially done for Google search, and then it was expanded to many other products at Google, and eventually it was used. It was also open source by Google. So obviously Google deserves a ton of credit for what they contributed to the industry that sparked all this revolution. I feel myself extremely lucky and proud that I was part of that amazing journey. So on a super high level, what BERT does, it's basically kind of this Mad Libs game that as we train or pre-train, we basically hide roughly 20% of the word. And we're asking the neural model to try to guess those words. To some extent, it's basically predicting what's the right words to be used. For example, in this case, words at the top, like grass, habitats, cold ground, marbles, small, are basically hidden. And just to guess new words is not necessarily that useful. But if you train the model on an insane amount of data from billions of training corpus, it starts actually being very good in trying to create a question answering framework. So, for example, the question is, what are the mammals that build their nest on the ground? And you give them context that most birds and some mammals, like those squirrels, build their nest high in the trees. And then you say some animals like geese, swans, wolves, raccoons, and skunks. In this technology, it basically allows the model to predict the right words, that the right answer is wolves, raccoons, and skunks. That's on the super simplistic level what BERT did.